Associate Professor, Department of Chemistry, PSL College of Engineering and Technology. Today's topic is fuels and combustion. First topic is introduction. A fuel is a combustible substance containing carbon as the main constituent which on proper burning gives large amount of heat that can be used economically for domestic and industrial purpose. During this process, the combustion of fuel, the atoms carbon, hydrogen, etc. combine with oxygen with simultaneously liberation of heat. Carbon react with oxygen to give carbon dioxide plus 94 calories, heat is liberated. Then hydrogen is combined with oxygen to give water molecules 68.5 calories, heat is liberated. The main source of fuel is coal and petroleum. These are stored fuels available in earth crust and generally called fossil fuels. Fossil fuels means the fuels derived from under the earth, we are call it as fossil fuels because they were formed from fossilized remains of the plants and animals. Then second one is the classification of fuels. What are the classification of fuels? First one, primary fuels, which are occur in nature such as coal, petroleum and natural gases are primary fuels. Then secondary fuel. Secondary fuels derive from the primary fuels, example coke, gasoline, coal gas, etc. Both primary and secondary fuels may be further classified based on their physical state. And then first one, solid fuels. Solid fuels examples of coal. Then liquid fuels. Liquid fuel examples petroleum. Then gaseous fuels. Gaseous fuels are natural gas. Then the calorific value. What is meant by calorific value? Calorific value means the total quality of heat liberated when a unit mass of fuel is burned completely. Then units of heat means calorie, kilocalorie, BTU. Then HCV and LCV. HCV, the expansion of HCV is highest or gross calorific value. The higher calorific value is total amount of heat produced when unit mass volume of the fuel has been burned completely and product of combustion have been cooled to room temperature. Then lower or net calorific value. Net or lower calorific value is the net heat produced when unit mass volume of the fuel is burned completely and the product are permitted to escape. Then net calorific value. What is the formula of net calorific value? Means the net calorific value is equal to gross calorific value minus latent heat of condensation of water vapor produced, that equals to GCV minus mass of hydrogen per unit weight of fuel burned into 9 into latent heat of concentration of water vapor. Next one, Dulong's formula. Dulong's formula for calorific value from the chemical compositions of the fuel. HCV is equal to 1 divided by 100, 8080 carbon and 34,500 hydrogen minus oxygen divided by 8 plus 2240 sulfur, where CHO, carbon, hydrogen, oxygen and sulfur are the percentage of carbon, hydrogen, oxygen and sulfur is a fuel respectively. Then LCV, HCV minus 9H divided by 100 into 587. Then is equal to HCV minus 0.009 hydrogen into 587 calories. This is based on the fact that 1 part of hydrogen by mass gives 9 parts of water and latent heat of steam is 587 calories per gram. Solid fuel. The best example of solid fuel is coal. Coal is regarded as a fossil fuels produced from large accumulation of vegetables debris due to partial decay and the alterations by the action of heat and pressure over millions of years. It's chiefly composed of carbon, hydrogen, nitrogen and oxygen besides non-combustible inorganic matter. Then classification of coals. The coals are classified on the basis of their rank. A rank is defined as the degree or extent of maltrations in its, therefore a quantitative measures of carbon content. The classification of coal, the first stage is wood. Then second one peat, then lignite, bituminous coal and anthracite. These all the classification, all the stages of only vary in percentage of carbon. Then analysis of coal. In order to assess the quality of coal, following two types of analysis. First one proximate analysis, second one ultimate analysis. Proximate analysis, it includes the determination of moisture content, volatile matter as and fixed carbon. This gives quick and valuable information regarding commercial classification and determination of suitably for a particular industrial use. Then second one is ultimate analysis. It includes the determination of carbon, hydrogen, nitrogen, sulfur and oxygen in coal. Since it is used for the determination of elements present in the coal, it is also called elemental analysis. Then proximate analysis. In the proximate analysis, we have found out the moisture content. There was a formula of moisture content. Percentage of moisture is equal to loss in weight divided by weight of coal taken into 100. Then about 1 gram of finely powdered air dry coal sample is weighed in a crucible. Then crucible is placed inside an electric hot air oven. Then maintain the temperature at 105 degree to 110 degree centigrade. Then crucible is allowed to remain in oven for 1 hour and then taken out. Coal is a desiccated and weighted. How much amount of weight is lost means the percentage. This is the formula, the percentage of moisture. How much amount of weight is lost divided by weight of coal taken into 100. Then second one is volatile matter. Then dried sample is coal left in the crucible is first, is then covered with a lid and placed in an electric furnace. The electric furnace, another one name is muffled furnace. Maintain at the temperature 925 degree plus or minus 20 degree centigrade. The crucible is taken out of the oven after 7 minutes of heating. Then crucible is cooled first in air, then inside a desiccator and weighted again. Loss in weight is reported as volatile matter on percentage basis. The percentage of volatile matter is equal to loss in weight due to removal of volatile matter and weight of coal sample taken in volatile matter to 100. This is the percentage of volatile matter. Third one is ash content. The coal is in the crucible is then heated without lid in a muffled furnace. The maintain at the temperature is 700 plus or minus 50 degree centigrade for half an hour. The crucible is then taken out, cool first air, then in desiccator and weighted. Heating, cooling and weighting is repeated till a constant weight is obtained. The residue is reported as an ash on percentage basis. The percentage of ash is weight of ash left divided by weight of coal taken into 100. Then fixed carbon. Fixed carbon means the final. The percentage of fixed carbon is equal to 100 minus the percentage of moisture content, volatile matter plus ash content. High percentage of fixed carbon is desirable. That is a good coal. Proximate analysis, the first one moisture content. What's the percentage of moisture content? We can find out. The formula is loss in weight of moisture divided by weight of coal is taken into 100. Then second one volatile matter. We can find out the volatile matter in this formula. The percentage of volatile matter is loss in weight of due to the removal of volatile compound divided by weight of coal sample is taken volatile matter into 100. Then third is ash content. The percentage of ash content, the formula is weight of ash left divided by weight of coal taken into 100. The final, the fixed carbon. We can find out the fixed carbon percentage is equal to, use this formula, 100 minus percentage of moisture content plus volatile matter plus ash content. Then high percentage of fixed carbon is desirable. Then second process is the importance of proximate analysis. The proximate analysis provides the following valuable information is quality of coal. First one, moisture. Moisture lowers the effective calorific value of coal. but moreover is quench the fire in the furnace. Hence, the lesser the moisture content, better the quality of coal as a fuel. Moisture content is less means the quality of coal is best. Then volatile matter. A high volatile matter containing coal burns with a long flame, high smoke and low calorific value. Hence, lesser the volatile matter, better the rank of the coal. Higher volatile content in coal is undesirable. Then high volatile matter content means that high proportions of fuel will be distilled and burned as gas or vapor. The volatile matter present in the coal may be combustible gases. The combustible gases are such as methane, hydrogen, carbon monoxide and other hydrocarbons. Hydrocarbon means the hydrogen and carbon content present in the compounds are the hydrocarbons. That is a common name of the substance. Or non-combustible gases. Non-combustible gases, the carbon dioxide and nitrogen. Then ash is a useless non-combustible matter which reduces the calorific value of coal. Lower the ash content, better the quality of coal. The presence of ash also increase in transportation and handling and storage causes. The presence of ash also causes wear of furnace walls, burning of apparatus and feeding mechanism. Then fixed carbon. Higher the percentage of fixed carbon, greater its calorific value and better the quality coal. Greater the percentage of fixed carbon, smaller is the percentage of volatile matter. This also represents the quality of carbon that can be burned by a primary current of air drawn through the hot bed of the fuel. Significance of ultimate analysis. Carbon and hydrogen content. Greater the percentage of carbon and hydrogen, better is the coal's quality and calorific value. However, hydrogen is mostly associated with the volatile matter and hence it is affect the use to which the coal is put. It's also higher percentage of carbon in coal reduce the size of combustion chamber required. The amount of carbon, the major combustible constituent of coal, depends on the type of coal and its percentage increase with the rank from lignite to anthracite. Then second one, nitrogen. It has no calorific value and hence its coal is undesirable. A good quality of coal should have very little nitrogen content. The nitrogen content we can find out about 1 gram of actually weighted powdered coal is heated with a concentration of sulfuric acid along with catalyst potassium sulfate in a long neck flask, and that is Heldall's flask. After the solution becomes clear, it is treated with excess of potassium hydroxide and the liberated ammonia is distilled over and absorbed in a known volume of standard acid solution. The unused acid is then determined by back titration with standard sodium hydroxide solution. From the volume of acid used by ammonia liberated, the percentage of nitrogen in coal is calculated as follows. The percentage of nitrogen, volume of acid used into normality into 1.4 divided by weight of coal taken. This is nitrogen content. We can easily find out the percentage of nitrogen content in this process. Sulfur, although contribute to the heating the volume of coal, yet on combustion produced acid, sulfur dioxide and sulfur trioxide, which have the harmful effect of corroding the equipments and also cause atmospheric pollution. Sulfur is usually present to the extent of 0.5 to 3.0 and derived from ores like iron, pyrites, gypsum, etc. mines along with the coal. The percent of sulfur is highly undesirable in coal to be used for making coke for iron industry, since it is transformed to the iron metal badly affected the quantity and the properties of steel. Moreover, oxides of sulfur formed as the combustion product pollute the atmosphere and leads to corrosion. Then oxygen content decrease the calorific value of coal. High oxygen content coals are characterized by high inherent moisture, low calorific value and low working power. Moreover, oxygen is the combined form with hydrogen in coal, and thus hydrogen available for combustion is lesser than actual one. An increase in 1% oxygen content decrease the calorific value by about 1.7%. Hence, oxygen is undesirable. Thus, a good quality of coal should have low percentage of carbon. The low percentage of carbon means the coal quality is very good. Then another one is ultimate analysis. Another one content we can find out the percentage of carbon and hydrogen. About 1.2 gram of actually weighted coal sample is burned in a current of oxygen in a combustion apparatus. Carbon and hydrogen of the coal are converted into carbon dioxide and water respectively. The gases product of combustion are absorbed respectively in KOH and calcium chloride tube of known weight. The increase in weight of these is determined. Then we can find out the carbon content percentage. Increase in weight of KOH tube into 12 into 100 divided by weight of coal sample taken into 44. Then 12 means the molecular weight of carbon. Then percentage of hydrogen, increasing weight of calcium chloride tube into 2 into 100 divided by weight of coal sample taken into 18. 2 means hydrogen molecular weight and 18 means water molecular weight. Then it can be easily find out the carbon and hydrogen content present in the coal. Then sulfur content, it is determined from the washing obtained from the known mass of coal used in a bomb calorimeter for determination of a calorific value. During this determination, sulfur is converted into sulfate. The washing and treated with barium chloride solution, when barium sulfate is precipitated, then precipitate is filtered, washed and heated to constant weight. Then formula, using this formula we can find out the percentage of sulfur. The weight of barium sulfate is obtained into 32 into 100 divided by weight of coal sample taken in a bomb into 233. Then ash content, and the ash content is already told that proximate analysis, refer that proximate analysis in ash determinations. Then oxygen, it is obtained by difference. The percentage of oxygen is equal to 100 minus the percentage of carbon, hydrogen, sulfur and nitrogen plus ash content. In ultimate analysis, we can find out the nitrogen. That's the person. Nitrogen, find out the process using the Heldal's flask. Then the formula is percentage of nitrogen is volume of acid used into normality into 1.4 divided by weight of coal taken. Then carbon and hydrogen content. Carbon means increasing weight of KOH tube into 12 into 100 divided by weight of coal sample taken into 44. The percentage of hydrogen, the increasing weight of calcium chloride tube into 100 divided by weight of coal sample taken to 8. Sulfur, the percentage of sulfur formula, weight of barium sulfate obtained into 32 into 100 divided by weight of coal sample taken in a bomb into 233. 233 the molecular weight of barium sulfate. Then percentage of oxygen, the final formula is, we can find out the percentage of oxygen 100 minus the percentage of carbon, hydrogen, sulfur, nitrogen plus ash content. These are the process of ultimate analysis. Then liquid fuels. The solid fuel is best example is coal. Then coal classification, then the analysis of coal, proximate analysis and ultimate analysis. Then liquid fuel. The example of liquid fuel is petroleum or crude oil is a dark greenish brown. or black colored viscous oil found in deep in earth crust. The oil is usually floated over a brine solution, and above the oil natural gas is present. Brine solution means the salty content mixed in the water means the brine solution. Crude oil is containing the mixture of paraffinic, olefinic and aromatic hydrocarbons with minor amount of organic compounds like nitrogen, oxygen and sulfur. The petroleum or crude oil is first derived from under the earth. The petroleum having so many impurities or so many byproduct are having in the crude oil. The byproduct are paraffin, olefin and aromatic hydrocarbons, then present in some of the organic compounds also, nitrogen, oxygen and sulfur. Then the petroleum is purified. We need the purified the petroleum. The byproducts are can be easily removed that purification purpose. The average composition of crude oil is carbon content 80 to 87%, hydrogen content 11 to 15%, sulfur content 0.1 to 3.5%, nitrogen plus oxygen is very low percentage 0.1 to 0.5%. Then now we can need the purified that petroleum. Next only the petroleum is used as the vehicular fuels. Then classification of petroleum. First one, paraffinic base type crude oil. It contains saturated hydrocarbons from CH4 to C35H72 and little amount of naphthalene and aromatic. Saturated hydrocarbons means the hydrocarbons does not undergo any type of reaction. It is saturated. Carbon and hydrogen content present in the substance that we are called it as saturated hydrocarbons. Then asphaltic base type crude oil, it contains mainly cycloparaffin or naphthalene with smaller amount of paraffin and aromatic hydrocarbon. Then mixed base type crude oil, it contains both paraffinic and asphaltic hydrocarbons and are generally in the form of semi-solid gases. Then three types of petroleums, the classification. Then mining and refining of petroleum. The crude oil is obtained from the earth crust containing water, sulfur and some unwanted impurities. After the removal of water and sulfur and these impurities, the crude oil is separated into various useful fractions by fractional distillation and finally converted into desired specific product having different boiling point. The process is called refining of petroleum, and the refining of plants is called oil refineries. The process of refining involves the following step. The crude oil is derived from earth crust. The crude oil contains some of the water, sulfur and unwanted impurities. So we can need the refining of petroleum. Then only the petroleum is used as the vehicular fuels. Then first step 1, the purification. The step 1 is separation of water. Separation of water. The crude oil from the oil well is extremely stable emulsion of oil and salt water. Then crude oil is allowed to flow between two highly charged electrodes, where the colloidal water droplets are collapsed to form large drops in form separate out from the oil. The crude oil is emulsion formation, that is curd, that like curd formation mixed with oil and salt water. Then that crude oil is passed through the highly charged electrode. Then the colloidal water droplets are combined to large droplet. Then we can easily remove. Then second step, removal of harmful impurities. The presence of sodium chloride and magnesium chloride in the crude oil can corrode the refinery equipments. Hence, these salts are removed by electrical desalting and dehydration methods. The sulfur compound present in the crude oil is removed by treating oil and copper oxide, which result in the formation of copper sulfide, which is then removed by filtration. Maybe the sulfur compound present in the crude oil means it can be easily removed by treating the copper oxide. Then resulting the formation of copper sulfate means the remove by filtration. Then fractional distillation. Step 3 is fractional distillation. Step 1 is the water removal. Step 2 is sulfur removal. Then step 3 is fractional distillation. The crude oil is then heated to about 400 degrees centigrade in an iron retard, whereby all volatile substances except asphalt or coke are evaporated. Then cod vapors are then passed up to the fractionating column, which is a tall cylindrical tower containing number of horizontal stainless steel tray and short distance. Each tray is provided with a small chimney covered with a loose cap. Here the diagram. This is the tray. Then top of the tray is loose chimney cap. Then the vapors of oil goes up to the fractionating column. They become gradually cooler and get condensed at different height of column. The fractionating have higher boiling points, condensed at lower tray, whereas the fractionating having lower boiling points, condensed at the higher tray. The gasoline obtained by the fractional distillation is called Stryton gasoline. Various fractions obtained at different trays are given in the table. And this is the fractional distillation column. Higher boiling points product is condenses lower tray. Lower boiling point condenses the higher tray. And what's the byproduct? Lubrication oil, diesel oil, kerosene, naphtha, gasoline and petroleum. These are the byproduct. This is the tray. The tray is top that chimney. This loose cap. The crude oil is passed through this way. Then is passed through this column. Lower boiling point condensed is the upper tray. This is the diagram of fractional distillation of crude oil. Then various fractionals, various crude oil is combustion uses. Name of the fraction: condensed gases. The boiling range is 30 degrees centigrade. Hydrocarbon C1 to C4. What are the uses of uncondensed gases, domestic and industrial fuel, and under the name of LPG, liquefied petroleum gas. Then petroleum either 30 to 70 degree. Then it's used as a solvent. Gasoline and petrol, boiling range 40 to 120 degrees centigrade. Then uses as motor fuel and solvent in a dry cleaning. Then naphtha and solvent split 120 to 180 degrees centigrade, C9 to C10 as a solvent and in dry cleaning. The kerosene oil, the boiling range 180 to 250 degrees centigrade, C10 to C16. The composition of hydrocarbon as a fuel for jet engines and an illuminant. Then sixth one is diesel oil or gaseous oil, 250 to 320 degrees centigrade, C10 to C18. The hydrocarbons, compositions of hydrocarbons used as diesel engine fuel. Then heavy oil, boiling range 320 to 400 degrees centigrade. C in the hydrocarbons range C17 to C30. Production of gasoline by cracking process. These are the byproduct of refining of petroleum. Then various fractions recovered from the heavy oil. Lubricating oil. Then composition C17 to C20 used as a lubricant. The petroleum jelly used in medicines and cosmetic, paraffinic bags, candle from wood polish, etc. Grease as a lubricant. Asphaltus and bitumen is used for making roads and waterproof roofing. Then hydrocarbon range is C30 and above. Then flue gas analysis. Flue gas means the mixture of gases coming out from the combustion chamber. Flue gases: carbon dioxide, oxygen and carbon monoxide. These three things are mixed. We are call it as the flue gas analysis, that is RSET method. The analysis of flue gas would give an idea about the complete or incomplete combustion process. If the flue gases contain the considerable amount of carbon monoxide, It indicates that incomplete combustion and it contained a considerable amount of oxygen indicate complete combustion. The analysis of flue gas is carried out by the using RSET apparatus. Description of RSET apparatus. It consists of a horizontal tube, 3-way stopcock. One end tube containing fused calcium chloride is connected. The other end tube is connected with a graduated burette. The burette is surrounded by a water jacket to keep the temperature of gas constant. The lower end of the burette is connected to a water reservoir by means of a rubber tube. The level of water in the burette can be raised and lowered by raising or lowering the reservoir. The horizontal tube is also connected with 3 different absorption bulbs, 1, 2, 3 for absorbing carbon dioxide, oxygen and carbon monoxide. These are the RSET apparatus. 3-way stopcock, 1, 2, 3. These are the 3 bulbs. This is water reservoirs. There is a rubber tube, lower and upper of the rubber tube, filling the level of the water in this bottle. These are the description of RSET apparatus. Bulb 1, it contains potassium hydroxide solution and it absorbed by carbon dioxide. Then bulb 2, it contains alkaline pyrocolloid solution and it absorbed carbon dioxide and oxygen. And then bulb 3 means it contains ammoniacal cuprous chloride solution and it is absorbed only carbon dioxide, oxygen and carbon monoxide. Then working. Here is the bulb. The first one, second one and third one. First bulb, potassium hydroxide, it is absorbed carbon dioxide. Then second bulb is alkaline pyrocolloid, that is ammoniacal cuprous chloride. Then working. First bulb is absorbed carbon dioxide, second bulb is absorbed carbon dioxide and oxygen, third bulb solution is absorbed only carbon dioxide, oxygen and carbon monoxide. Then 3 working means the 3-way stopcock is open to the atmosphere and the reservoir is raised till the burette is completely filled with water and air is excluded from the burette. The 3-way stopcock is now connected to the flue gas supply. The flue gas is sucked into the burette. The volume of flue gas is adjusted to 100 cc by rising and lowering the reservoir. Then the 3-way stopcock is closed. The first process, the absorption of carbon dioxide. The stopper of the bulb 1 containing KOH solution is open and all the gases is passed into the bulb 1 by raising the level of water in the burette. The gas entered into the bulb where the carbon dioxide present in the flue gas is absorbed by KOH. The gas is again sent to the burette and the process is repeated several times to ensure complete absorption of carbon dioxide. Then decrease in the volume of flue gas is the burette indicate the volume of carbon dioxide in 100 cc of the flue gas. Then second bulb. Second bulb absorption of oxygen. The stopcock bulb 1 is closed and the stopcock bulb 2 is open. The gas is again sent to the bulb 2 and the oxygen present in the flue gas is absorbed by alkaline pyrocolloid. Alkaline pyrocolloid means 925 gram of pyrocolloid plus 200 gram of KOH in 500 ml distilled water. The decrease in volume of the flue gas in the burette indicate the volume of oxygen. Then absorption of carbon monoxide. Now stopcock the bulb 2 is closed and stopcock bulb 3 is open. The remaining gas is sent into the absorption bulb 3 where CO present in the flue gas is absorbed by ammoniacal cuprous chloride. Ammoniacal cuprous chloride means 100 gram of copper chloride plus 125 milligram liquid ammonia plus 375 milligram distilled water. The decrease in the volume of the flue gas in the burette indicate the volume of carbon monoxide. The remaining gas in the burette after the absorption of carbon dioxide, oxygen and carbon monoxide is taken as nitrogen. These are the apparatus, 3 bulbs. The first bulb is absorbed carbon dioxide, second is oxygen, third one is carbon monoxide. This is the RSET apparatus. We can find out the flue gas analysis in the RSET apparatus. Thank you.